Stability of oxidation states. Let us coming to outermost electronic configuration, NS2NP3. NS2NP3. See, when 50A group element loses 3 electrons from the p orbital, it shows +3 oxidation state. And when it loses 5 electrons at a time, it shows +5 oxidation state. It is considered as lower oxidation state. Lower oxidation state. It is considered as higher oxidation state. Lower oxidation state and a higher oxidation state. Okay, +3 is the lower, +5 is the higher. Several times questions came in the weekend exams and in the final NEET also, even JEE also. Arrange the following oxidation states in the increasing or decreasing order of their stability. Clear? I am giving one statement to you. See, first statement, as we move down the group, lower oxidation state stability, increases. Lower oxidation state stability increases. As we move down the group, lower oxidation state stability increases. We have a reason also. What is the meaning for this statement? I will give you everything and application of this statement also. Okay, first write statements, later we will discuss what is the meaning for this statement, why it is happening. Okay, next, as we move down the group, this is increasing, note down careful. As we move down the group, higher oxidation state stability, decreases. Higher oxidation state stability decreases. Let us start our discussion. Most important and question coming area in the weekend exams and final NEET also. First statement, as we move down the group, lower oxidation state stability increases. I am taking last 3 elements. What are 50A group elements? Nitrogen, phosphorus, arsenic, antimony and bismuth. If I read 10 times, automatically you will get this order. Okay, elements list. Take last 3 elements. Why we are taking last 3 only? Because removal of electrons from last 3 elements is easy, because they are having low ionization energy. As we move down the group, IE decreases, so we can remove electrons easily. So by taking last 3, we will discuss the last 2 statements. Okay, arsenic +3, lower I am writing arsenic, antimony and bismuth. Sorry, liquids. Arsenic +5 higher, antimony +5 and bismuth +5. Now you tell, what happens as we move down the group? What happens to the stability of oxidation states? Increases or decreases?
+5 increases.
Lower oxidation state stability increases. Higher oxidation state stability decreases. Means you tell me here which symbol I have to keep, less than or greater than? Adiba?
Greater than.
First one, less than or greater than I have to keep? Less than. Most important, very important, which of the following stability order is correct? Okay, bismuth +3 is stable. This is stable oxidation state. For bismuth, which is stable oxidation state, tell me? +3. Bismuth exists in 2 types, Ba +5 and Ba +3, but which is stable? Ba +3 is stable. I'll explain the reason also. Okay, next. Higher oxidation state stability decreases, so greater than As plus phi is greater, Ba plus phi is unstable, less stable. This is greater stability, having greater stability. Stable. So for arsenic, which oxidation state is stable? Plus 5 is stable. Reason is important. Reason is important due to inert pair effect. Periodic table. Let us discuss what is inert pair effect. How they will give the statement. You know, SS and the reason type questions. Okay. The stability order of plus 3 is increasing or decreasing given, and the reason is inert pair effect. Correct. Lower oxidation state stability increases due to inert pair effect. Correct statement. Okay. Reason. Due to inert pair effect. Due to inert pair effect. What is inert pair effect? Let us see. First year periodic table only. Inert pair effect. That's why I am saying in second year in inorganic we use periodic table and chemical bonding concepts. Okay. For inorganic. For organic we use nomenclature and GOC. That's why I said to learn. If I start second year organic, everything is from the first year only. Okay. In the physical stoichiometry. So better to revise first year as soon as possible. Okay, reason is inert pair effect. What is inert pair effect? Let us see. Inert pair effect means, see, nitrogen is there, no? Nitrogen, phosphorus, arsenic, these elements are there, no? These elements can lose their electrons from the s orbital, outer s orbitals. You know, ns2, np3 is the outer configuration. That ns orbitals are there, no? Okay. These starting elements lose that outer s orbital electrons easily. Last element, heavier element, you know, bismuth do not lose this. Why? Because of poor shielding of f orbitals. Okay, f orbital screening capacity is less, na? So nucleus tightly hold that outer s electrons. So s electrons will not come out. If s electrons will not come out, how they form plus 5? Are you getting what is the general form? ns2 np3. What I am saying, due to poor shielding of f orbitals in the heavier elements, a nucleus hold this s electrons tightly, so removal of this s electron is difficult. That is called as inert pair effect. The reluctance of s orbital electrons, the reluctance means not interested in the bonding. The reluctance of s electrons to participate in the bonding is called as inert pair effect. Remember the order and reason. Generally they will ask just reason only. What is reason? Inert pair effect. I explained what is inert pair effect. Again I revised first year concept. Okay, inert pair effect. What is inert pair effect? The reluctance of s orbital electrons. As we move down the group, s orbitals show reluctance. They do not show interest to participate in the bonding. As we move down the group, s orbital electrons show reluctance to participate in the bonding. That's why formation of plus 5 is difficult. Okay, that's why unstable. If you forcefully remove, what happens? That will exist in the unstable form. For example, you remove forcefully s electrons from the bismuth. It exists in the unstable form. That's why this is less stable. This is more stable. Instead of that, remember direct orders and simple reason. As we move down the group, lower oxidation state stability increases. As we move down the group, higher oxidation state stability decreases. Enough. This is one question. And additionally, we are discussing another question when paper is very tough, especially you are elite, na? So they will give some tricky questions. Let us see the applications. You know which is stable and which is unstable. Clear? By seeing this, tell me which is stable. For bismuth, which is stable? For bismuth, which is stable? Plus 3 is stable. For bismuth, which is unstable? Plus 5. Adiba, correct only. Did you get Adiba this concept? Inert pair effect, everything. For bismuth, which is stable? Plus 3. Which is unstable? Plus 5. I am asking one simple question. For example, you are in some elite section, right? If you sit in an elite section, then you will feel stable and comfortable. For example, if I make you to sit in the Ames section, then what you will do? You will feel unstable. You always try to go to again elite section only. Okay? Because you are feeling comfortable and stable in the elite sections. If I make you to sit in the Ames section, you are not you won't feel comfortable, you won't feel stable. Again, you will try to go to elite section only. Clear? For bismuth, which form is stable form?
Plus 3.
Ba plus 3. Next, we are discussing very important point. Which of the following is a good oxidizing agent? Which of the following is a good reducing agent? Next step questions, next level questions. Okay. Once look at this order. For bismuth, which is stable, Ba plus 3 is stable. Ba plus 5. Tell me, Ba plus 5 is stable or unstable? For bismuth, which is stable?
Plus 3.
Plus 3 is stable. This is unstable. This is unstable. You tell me, unstable ion always try to convert it to
Stable.
stable. What is stable form for bismuth? Plus 3 is stable. Now you tell me how this conversion takes place. By losing electrons or by gaining electrons?
Gaining 2 electrons.
By gaining electrons, by gaining 2 electrons. Clear? Okay, bismuth plus 5 is waiting to steal the electrons from the others, or it is waiting. Some people are selling electrons in the market. Okay, he try to purchase the electrons. Why? Because it is in the unstable form. If it purchases 2 electrons, then it will convert it to stable form. Two options are there. Ba plus 5 has to purchase or it has to steal from the others. Yes or no? Stealing or purchasing. Two options. For example, one person is selling the electrons. He is going in the street. Okay. Ba plus 5 did one thing. Stealed 2 electrons instead of purchasing. Because to purchase, it has to spend money. Stealed 2 electrons and converted to
Stable.
stable form. Now you tell me, taking electrons from the others forcefully or removing electrons from the others, property is called as oxidizing property. The property of taking electrons from the others. Why it is taking electrons from this person? To get the stable form. Taking electrons from the others, stealing electrons from the others, accepting electrons from the others is called as oxidizing property. Ba plus 5 is a good oxidizing agent. Very important. Which of the following is a good oxidizing agent? Okay, now done. Bi plus 5 is a good oxidizing agent. Very important. It is good. It is good oxidizing agent. Very important questions. You will get 4 ions. Identify the good oxidizing agent from the given below. What is the reason here? See, Ba plus 5 is unstable. Ba plus 5 is unstable. So, it tries to convert. This is important. That's why I'm giving the reason also. Okay. ఏం కావాలి మళ్ళీ వస్తావా రావా మరి నాకు లైట్ స్క్రీన్ పడట్లేదు వెళ్ళు Ba plus 5 is unstable, so it tries to convert into stable Bi plus 3. Stable Bi plus 3 form by taking electrons from others. Taking electrons from others. Others is called as. Tell me, is called as which property? Oxidizing property. Sorry. Taking electrons from the others, removing electrons from the others. The property of taking electrons from the others is called as oxidizing nature, oxidizing property. Bi plus 5 is a good oxidizing agent. Why it is a good oxidizing agent?
Removal of electrons.
It is removing the electrons from the others. No? I'll tell you another simple reason, a simple explanation to understand this better. Why we are calling Bi plus 5 as a good oxidizing agent? Adiba, then you will get easy. I wrote one statement, you are having some little bit confusion, I'll clarify that. Clear? But you, for this concept, remember this story, okay? This arrows, one person is selling the electrons, this is better. But I'll tell you another explanation to you. See this. Bi plus 5 is unstable, right? Now A is one arbitrary element. A is one arbitrary element. For example, let us take magnesium. What is magnesium oxidation state here? 0. Neutral element, not 0. What Bi plus 5 will do? It will
Take.
removes or steals electrons from magnesium. How many electrons? 2. Why? Because if it gets 2 electrons, it will convert it to stable Bi plus 3. Then Adiba, you tell me, what about magnesium? Magnesium will convert it to?
Mg plus 2.
Magnesium will convert it to?
Mg plus 2.
Mg plus 2, Adiba. Mg plus 2. Right. You tell me, according to your redox reactions knowledge, document, Bhakti, 0 to plus 2 means this is which process? Oxidation or reduction?
Oxidation.
This process, oxidation or reduction, increase in the oxidation state is called as oxidation. Means magnesium is undergoing oxidation. Magnesium is undergoing oxidation means someone is doing oxidation. Who is that person? Bismuth. Bismuth is doing oxidation. So bismuth plus 5 is a good oxidizing agent. Clear? Adiba, now why we are calling Bi plus 5 as a good oxidizing agent? Because it is oxidizing magnesium. Oxidizing magnesium 0 to magnesium plus 2. 0 to plus 2 means oxidation only, na? Clear? It is removing electrons, taking electrons. Cut. Magnesium is a reducing agent. You know already, the one which undergoes oxidation is a reducing agent. The one which undergoes reduction is a oxidizing agent. Reduction, so it is oxidizing agent. Bismuth is undergoing reduction, so it is oxidizing agent. Got it? But very, very important. Once look at this. Coming to arsenic. For arsenic, which is stable form?
Plus 5.
Plus 5 is the stable form. Plus 3 is
Unstable.
unstable.
Reducing agent.
Arsenic plus 3. For arsenic, plus 3 is unstable. For arsenic, plus 3 is unstable. So plus 3 will try to convert it to plus 5. Plus 3 will try to convert it to plus 5. Okay, let us take one example. Arsenic plus 3. And let us consider oxygen is carrying 2 electrons. Oxygen is carrying 2 electrons. No, not like that. Now I am taking magnesium plus 2 here. Magnesium plus 2. Okay. If arsenic plus 3 gives 2 electrons, reverse. Arsenic converted to arsenic plus 5 and magnesium 0. In this reaction, magnesium is undergoing reduction. Magnesium is undergoing reduction. Arsenic is undergoing oxidation. The one which undergoes oxidation is a reducing agent. According to redox reactions, I am trying to explain. Okay. If I take general reaction, you may feel some confusion a little bit. That's why I am taking. Basically, As plus 3 is unstable. So I try to convert into As plus 5 by losing electrons or by giving electrons to others. It is giving 2 electrons to magnesium plus 2. Okay. So arsenic plus 3 is which agent? Final conclusion. Reducing agent, good reducing agent, direct questions. Good reducing agent. One student will say like this, sir, I'm getting confusion about this concept. Means just you remember which is oxidizing agent, which is reducing agent, enough. Okay, which is good oxidizing agent? Bismuth. Bismuth plus 5 or plus 3?
Plus.
Bismuth plus 5. Bismuth plus 5. It is a good reducing agent? Arsenic plus 3 over. Direct question will come. Which of the following is a good oxidizing agent? Which of the following is a good reducing agent? Remember that. I already given the explanation also. Okay. Right. Next, special features of nitrogen. Or anomalous behavior of nitrogen. Anomalous property of nitrogen. Special features of nitrogen. See, nitrogen is having unique properties when compared with other elements due to some reasons. First point, nitrogen has small size, more electronegative, small size and more electronegative. It can form multiple bonds with itself or with others, with other elements also, means with carbon also. For example, like this, multiple bond, triple bond, or like this also. Okay, due to its small size and high electronegativity, it can form multiple bonds with itself or with other elements. Read today only, Adiba and Bhakti. Okay?
NCERT.
Not NCERT, our notes. You are writing the notes now. If you open NCERT, okay, better only, but it takes more time. You have to arrange all important points at one place.
Atlane we can test to love also. Difficulty NCERT in the line system.
We covered all the points from the NCERT only. But see, if you go through NCERT directly, you cannot get. These explanations are not there in the NCERT. You can compare after completion of the lesson. You can compare how our lecture is very useful to you. You read NCERT only, but after our notes and our discussion, then you go with NCERT. It can form multiple bonds with itself and other elements. Next point. Nitrogen can form p-pi bonds. It cannot form p-pi d-pi bond. Reason is nitrogen cannot form p-pi d-pi bonds. Can you guess? In chemical bonding, we have this concept p-pi d-pi bonding. Why nitrogen cannot form p-pi d-pi bonding? Adiba, any guessing? Yes, due to absence of vacant d orbitals. Why vacant d orbitals are not present in the nitrogen? Once look at this diagram. This is useful for other concepts also. That's why I'm giving this diagram. First, second, third, fourth energy levels. In first energy level, which orbitals are present? 1s. Second, 2s, 2p. Third, 3s, 3p, 3d. 4s, 4p, 4d, 4f. Okay, in first 1s I wrote, right? In second 2s 2p, third 3s 3p, 3d I wrote. So d orbitals are starting from which energy level? Third energy level. What are second period elements? In second period, carbon, nitrogen, oxygen, fluorine. These are second period elements. See, nitrogen belongs to second period now. So is there any d orbital? No. Very important, useful in the organic also, like basic point, important point. In third period, silicon, phosphorus, sulfur and chlorine. Phosphorus containing vacant d orbitals because it belongs to third period. Nitrogen do not contains vacant d orbitals, that is the reason here. So write as an important point, nitrogen do not contains vacant d orbitals. Nitrogen do not contains vacant d orbitals. That's why it cannot form p pi d pi multiple bonding. Okay. And its bond energy is see, bond energy means here again we have two types of bond energies. Bond energy means I am talking about n triple bond n bond energy, n bond energy, not single, multiple bond energy. Very important, don't get confusion. N2 bond energy. Its bond energy means diatomic nitrogen we are discussing. N2 bond energy. N2 bond energy is more. Why N2 bond energy is more? Diatomic N2 we are discussing. Triple bond is there now, so strong bond. Double bond is weak. Single is weak. You cannot cut triple bond. So its bond energy is more. So its chemical inertness is more. Why nitrogen is chemical inert? Due to its more bond energy. Its bond energy is more. Mention particularly N2 because NN bond energy is different. We are discussing N triple bond and NN is different. Okay, mention NN, N triple bond N. Its bond energy, diatomic nitrogen, is more. So N2 dinitrogen, very important. N2 dinitrogen, we are discussing about dinitrogen. So N2 is chemically inert. At normal temperatures it is inert. Okay. In the air, N2 is there in a stable format only, this is in the stable format only. But when you increase temperature at drastic conditions, it will react with others. But normally it is inert. Why? Due to strong bond energy, chemically inert. Okay. Now let us consider single bonds. N single bond, N, P single bond, P bond energies. This is also very important. Comparing N single bond, P single bonds, like that. Next small heading, comparing N single bond. And single bond only mention in the bracket. N single bond, P single bond, and so on, dash. Can you guess which is having strong bond order, bond energy? This is nitrogen, in between one single bond is present. Phosphorus, one single bond is present. Which bond energy in the sense amount of energy required to break the bond. What is bond energy? Amount of energy required to break the bond. So which bond we can break easily? NN bond or PP bond or and so on. Nitrogen. Okay, I'll help you. Once look at this. NN. What is happening? You tell me. Yes. Bhakti, what is happening here? Radius is increasing. In generally, if distance between the atoms is less, attractions between them is more, and stability is more, you cannot break easily. So bond energy is more. Your distance is more, so attractions are less, so bond energy is less, so you can break bismuth bond easily. So based on this, can you guess which is having more bond energy? Adiba? NN bond energy is more compared to remaining, but exceptional. Like this only questions will come in your weekend exams. Exceptional case. Okay. Why exceptional case is observed here? The bond energy order is bond energy or bond strength. Energy or strength order. First of all, I will give the order bond energy or bond strength order. PP is greater than NN. After that, arsenic. After that, antimony. Then bismuth. Why PP bond energy is more than NN? Even though nitrogen size is small, according to general concept, N and bond should be cleaved with difficulty. You cannot break NN bond easily. But here breaking NN bond only easy, because nitrogen is having small size, and on nitrogen atom electron pairs are present. Now nitrogen is having how many lone pairs? One lone pair. Nitrogen is having one lone pair, oxygen is having two lone pairs, halogens are having three lone pairs on them. Like this one, see, nitrogen contains how many lone pairs? One. Oxygen contains how many lone pairs? Remember this general information according to periodic table. Okay, so nitrogen is having lone pairs and nitrogen size is small. Once look at this, what will happen? You tell me, you know Vesper theory?
Yes.
Valence shell electron pair repulsion theory.
Lone pair.
What is the order of repulsions there? Lone pair repulsion. Lone pair, bond pair, and bond pair. These two lone pairs try to repel with each other. This lone pair try to move this side, this lone pair try to move this side. Clear? So they try to move in the opposite direction because they repel. Negative. Electron pair means electron only. Electron means negative charge. Negative, what will happen? Repulsions will take place. Due to that repulsions, you tell me, these two nitrogen atoms also will move along with lone pairs or not? Lone pair is moving in that direction. Lone pair is present on which atom? Nitrogen atom. So nitrogen atom also try to move away. This nitrogen atom try to move in this direction. So two atoms are going in the opposite direction. Then cleavage is easy. We can cleave easily. That is the reason. So due to small size and high interelectronic repulsions, so nitrogen bond energy is less than pp. Got it, Chadiba? But size is more, no? So their lone pair repulsion cannot be taken into consideration. This distance is increasing, na? When distance is small, then only lone pair comes into operation. Got it? With size, as distance increasing, we do not consider lone pair repulsions. Okay? There we consider just a bond only, distance between the two atoms. Got it, Adiba? In case of nitrogen, they are small, the distance between them is less, their lone pair repulsions is operated. But here we cannot take consideration of lone pair repulsion. You can see, previous slide, just a second. See, Bhakti and Adiba, 90% questions will come from the notes only in our discussion only. 90% I will give the guarantee for your weekend exams, no doubt, for organic and inorganic. 90%, you can check. Because I am covering mostly all the points. If any one or two points missed, I will cover in the worksheets. We will go for worksheets discussion also, no, later. During worksheet discussion, if any one or two memory based questions missed, then I will cover that. Okay, Adiba. Now keep adding. Very, very important. Compounds of 5th A group. Compounds of 5th A group. Half of the lesson will be completed today only. Compounds of 5th A group. We have important compounds: hydrides, halides, oxides. Question coming here: hydrides, halides, oxides. Most of the chapter revolves around these three only, hydrides, halides, oxides, but very easy, very easy. Here you no need to by heart anything. If you get the concept, in inorganic also concept based questions are there. 50% memory based, 50% concept based. Okay, don't go for memory always. Try to learn the concept and try to answer. In hydrates, if you know one concept, you can answer 7 types of questions, 7 different questions. If you know one single concept, okay. Keep heading. First one, hydrates. First one, hydrates. Hydrates. First of all, let us know the definition of hydride. Hydride. Once look at this, binary compound. What is the meaning of binary compound? Binary compound means compound which is made up of 2 different elements. It's called as binary compound. Compound made up of 2 different elements. NH3. It is binary compound. Why it is a binary compound? Because it is made up of hydrogen and nitrogen. 2 are there. Okay, 3 hydrogens are there, but 2 only different, na? So NH3 is a binary compound. NO2 is a binary compound or not? Binary compound or not? Adiba. Binary compound only, na? You tell me the difference between NH3 and NO2, Adiba. NH3 is a binary compound, NO2 also binary compound, but what is the difference between them?
Hydrogen and oxygen. Element is different.
Binary compound of hydrogen is called as hydride. Binary compound of oxygen is called as oxide. Binary compound of oxygen. Binary compound of hydrogen. Okay, binary compounds of hydrogen are called as hydrides. So write the definition. Binary means made up of 2 elements. Binary compound of nitrogen. Sorry. Is called as hydride. Is called as hydride. Examples: NH3, PH3. We are taking 5th A group hydrates only. Dash. H2 also hydride, binary compound of hydrogen only. But in the 6th A we'll discuss about it. Okay. NH3, PH3 and so on, BiH3. Okay. 100% in the next exam, 2 questions will come from that. Note this point. If you won't get and ask me, stability of hydride, reducing property of hydride, basic character of hydride, boiling point of hydride, volatility of hydride, dipole moment of hydrides. Clear? If you know stability, you can answer remaining questions easily. First heading, stability of hydrides. First of all, write hydrides in the sequence: an ammonia, phosphine, arsine, stibine and bismuthine. These are the hydrides. Okay, we are going to discuss stability of these hydrides. Lewis basic character, reducing property, boiling points, volatility, dipole moment, bond angle. Okay, no need to by heart, 0 scope for by hearting. Okay, if you know the concept, then you can understand. Let us start stability. First property of the hydrides. Now we are going to discuss properties of hydrides. Explain what is a hydride. Let us see the properties of hydrides. First property, stability. Properties of hydrides. First property, Roman number 1, stability. It is also asked as thermal stability. Frequently it is coming like this. Stability or thermal stability, both are same. Which of the following hydride is thermally stable, thermally unstable? Thermally means when you heat, what happens? When you heat, will it decompose or not? That is meaning of thermal stability. If you heat, it will decompose easily. That is thermally unstable. If you heat, it won't decompose. That is thermally stable. Okay, right. See, with this small story or point, you can remember concept. See, NH, PH, same concept. Two atoms are close to each other, then attraction forces are more, then stability is more. Okay, one general example, you and your friend is staying in single room, then affection is more in between you. Okay, instead if you stay in one room, your friend stay in another room, then what happens? Bond will break slowly, affection will decrease. When you close together, then affection is more. Similarly, if two atoms are close together, attraction force is more in between them, then you cannot break easily. Amount of energy required to break the bond is called as bond energy. Bond energy. Which is having more bond energy, NH bond or PH bond? Which is having more bond energy? Which bond we cannot break easily? NH. Why? Because between N and H distance is less. If distance is less, attraction force is more. If attraction force is more, then you cannot break easily. Which is having more bond energy? NH. If bond energy is more, then stability also more. Stability is more. Got it, Adiba? NH bond is strong bond. So stable bond. Stable bond. So what I am writing, as we move down, see, the radius increases. Bond length, radius, bond length increases or bond length increases. Stability decreases. Bismuth and hydrogen bond is less stable. Why? Because distance is more, attraction forces are less. You can break easily, you can cut this bond easily. As we move down the group, bond length increases, stability decreases. So which is more stable hydride? NH3. Yes or no? NH3 is more stable hydride. More stable or thermally stable. So stability order. NH3, PH3, thermally stable hydride. Which is thermally stable hydride? Ammonia. NH3 is thermally stable or simply stable. Thermally stable hydride. As we move down the group, distance between the atoms increases, attraction force decreases, so you can break the bond easily. So stability is less. You cannot cut NH bond because attraction forces are more, stability is more. Thermally least stable is bismuth ion, BaH3. Adiga, okay? Next, see, based on this single point, we can expand the concept. Stability is okay for everyone. Next, reducing property depends on the stability concept. Okay, now you tell me once, BiH bond is stable or not stable? Not stable, right? So you can break this bond easily. Hydrogen will come out easily. Okay, hydrogen will come out easily. Why hydrogen will come out easily? Because you can break this bond easily. Why you can break this bond easily? Because bond strength is less. Okay, less stable. You can break it easily. So which compound release hydrogen easily? Which is unstable, that will release hydrogen easily. BaH3 is unstable. This is unstable, so it releases hydrogen easily. The ability to release nascent hydrogen is called as reducing property. Reducing property depends on this concept only, stability concept only. Got it? Reducing property means it is the ability of hydride to release nascent hydrogen, single hydrogen atom. Which compound release hydrogen easily? BaH3. Why BaH3 release hydrogen easily? Because of less bond strength or instability. Unstable, so easily decompose, easily gives H. Clear? Next concept, next property. Stability is over now. Reducing property. Next, second characteristic property of hydrides, reducing property. Reducing property. First of all, write what is reducing property. It is the ability of hydride to lose hydrogen. So I'm giving one general reaction. MH3 is the hydride. It is losing hydrogen, nascent hydrogen. Single hydrogen atom is called as nascent hydrogen. MH3 is losing hydrogen. It is decomposing into MH2 and H. This is general reaction. Clear? Which decomposes easily? Which is unstable. Which is unstable? Last hydride is unstable. Clear? Once again write that NH PH dash 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 PiHC. Bond length is more, stability is less. You can break BiH easily. So release of BiH is easy. It is the ability of hydride to lose or to release hydrogen is called as reducing properties. So which hydride reduces more, means having reducing property more? BiH3, bismuthine. So order. BiH3 is a good reducing agent. It is reverse to stability. BiH3 is a good reducing agent. It is a good reducing agent. RA stands for good reducing agent. Adiba, any doubt? Sorry? What is the first property of hydride? Stability. Second property? Reducing agent. Third property? Lewis basic character. You can write here BiH bond is less stable, so release of hydrogen is easily, like that one statement you can write. BiH bond is less stable, so we can break BiH bond easily and release of hydrogen is easy. Write in our own words. And next, Lewis basic character. Adiba, what is Lewis base according to ionic equilibrium? What is Lewis base? Yeah, Lewis basic character. Lewis basic character. All are important only, but most important, Lewis basic character. What is the Lewis base, Bhakti?
Proton.
Lewis base. Electron pair donor. Electron pair donor. Or proton acceptor. Proton acceptor. But this statement is useful. Electron pair donor is called as Lewis base. See, which hydride donates electron pair easily? Which hydride donates electron pair easily? Bhakti, can you guess?
NH2.
I am taking NH3 and BaH3. Any guessings? See, 50A group element is having one lone pair. Nitrogen is having one lone pair and bismuth is having one lone pair. And imagine H plus is waiting for the electrons. Just one general comparison. H plus is a beggar waiting for money. Electron is money, right? Nitrogen is one person, bismuth is another person. Which person donates money or donates electrons to this beggar?
NH3 because it has more lone pair functions.
Which donates electrons easily? NH3. Nitrogen, Adima? You are also nitrogen. Why? What is the reason?
Repulsions. Lone pair.
Adima, your voice is coming very slow. She is saying bismuth, you are saying nitrogen. Which is correct? Let us see. I'll explain one small story to you. You are a very rich person, okay? God is giving money to you. But one condition he kept, God. I'll keep money on your head. Okay? God said to you like that. He will keep money continuously on your head. Like 1 lakh bundles, 1 lakh rupee bundle, another bundle, another bundle. Then what happens? Up to certain extent only you can lift that money, right? After that what happens? You cannot lift. Then what you will do? God will continuously keep the money on your head. Then you will give to poor people or any your friends. God will keep the money. You will keep to others. Clear? Then you will become donor or not? Good donor only. Right. Means on your head less weight should be present. Less weight should be present on your head. Then only you will be stable. Right? Nitrogen already carrying some weight, some electrons on its head. And these are surrounding hydrogens. Here also bismuth is carrying some electrons on its head. Clear? Okay. In this bond how many electrons are present? In this bond how many electrons are present? In each bond how many electrons are present? 2 electrons are present in each bond. Nitrogen and hydrogen, which is more electronegative? Nitrogen and hydrogen, which is more electronegative? Nitrogen is more electronegative. So these two bonded electrons try to move towards nitrogen. These two bonded electrons try to move towards nitrogen. These two bonded electrons try to move towards nitrogen. Then what happens to electron density on the nitrogen atom? Increases. Small size nitrogen cannot hold more electron density on its head. So it loses easily or donates easily. This donating capacity is called as basic nature. Electron pair donor is base, na? So NH3 is a good base. In case of BiH3, bismuth is not that much electronegative. Okay, these bonded electrons won't transfer to bismuth. Bismuth is having less density only. Why it gives electrons? It is only having less electrons. How it gives to others? Got it? Clear? These electrons won't move towards bismuth. Why? Because bismuth is a less electronegative. Clear? Sir, hello? Sir.
నేను మాట్లాడతాను కానీ మనం ఏగానే మాట్లాడి మార్క్స్ బాగుండదు. ఈవిడనే బాగా చేశాడు కానీ ఇప్పుడు ఏ కానీ మనం మాట్లాడుతున్నాం వెళ్ళిపోవడానికి ఇట్లా మాట్లాడుతున్నాం అదే మీరు ఎదురు వెళ్ళిపోండి ఎవరైనా కోఆర్డినేట్ చేసుకుంటాం.
ఓకే ఓకే
అది ఇదే కంటే అయితే
సరే సరేలేండి సార్. ఓకే ఓకే
ఏ కానీ ఇది వద్దు అదే అంటే బాగుంటుంది.
అదేలేండి సరేలేండి సార్ మరి. ఓకే రైట్ రైట్. Adiba, why ammonia is a good Lewis base? Did you get the concept? Please tell me. Why ammonia is a good base? Good Lewis base? It is. You, Bhakti, why ammonia is a good Lewis base?
More electronegative, so electron density on small size nitrogen increases, hence its tendency to donate electrons.
Donate.
So it is a good Lewis base.
Yeah. So can you arrange the hydrates in the increasing order of their Lewis basic character? What is the order?
NH3 greater than pH.
What is the order? NH3. NH3 is a good Lewis base. NH3, PH3, ASH3, SPH3 and BaH3. For these points or explanations, we have to listen to the classes. In NCERT, they won't give explanation like this. They'll give the direct order. Adiba, okay for you? Adiba. Once write the reason for important concepts. Reason. Nitrogen is simple reason, shortcut. Nitrogen is more electronegative. Nitrogen is more electronegative. It withdraw. It means nitrogen. It withdraw surrounding. It withdraw surrounding bonded electrons towards itself. So electron density on nitrogen atom increases. Electron density on nitrogen atom increases. Small size nitrogen cannot hold more electrons on it. So it readily loses, or we can use donate also. Donates to others. This donating property is called as Lewis basic property. Okay, so NH3 is a good Lewis base. NH3 is a good Lewis base. In your class, they'll give direct order only. Okay, they won't explain all these things due to time factor. So we are discussing properties of hydrides. We completed stability, we completed reducing property, we completed Lewis basic character. Next property, boiling point of hydrides. Let us finish hydrides and let us close. Okay, more 10 minutes, 5 to 10 minutes I need. Only 2 other properties are there. Let us complete that. Next, boiling point of hydrides. Boiling point of hydrides. And one more important point, daily I will post the video lectures in the YouTube. Okay, don't share to others. any your friends because they won't join in the tuitions.
So
Okay.
are they private and also
Private only, but
51 views వచ్చి అందుకే అడిగింది.
private only, but our students only watched that, no new student. I'll change the channel name only for you. I'll create one separate channel, but don't go to your friends because they won't join in the tuitions. But why I'm posting, because you can listen second time, third time if you want to get more command on the concepts. By night or morning every day I'll post the class. Okay. Boiling point of hydrates. What is the meaning of boiling point? According to chemical bonding, in chemical bonding you studied orthonitrophenol boiling point, metanitrophenol boiling point, orthonitro, metanitrophenols boiling points, which is having less boiling point, more boiling point, volatility. Boiling point, general definition I am giving, it is not formal definition. Boiling point means the temperature at which compound just boils is called as boiling point. Okay, formal, not formal, just general definition. Which is having more boiling point, NH3, PH3, ASH3. Guess, Pradipha. NH3 is having more boiling point. In all cases you have one relation, Adiba. What is that relation? Boiling point is directly proportional to molecular weight. If molecular weight is same, then boiling point is depends on the branching. Are you getting idea? In organic chemistry I given this. Boiling point is directly proportional to molecular weight. If molecular weight is more, then boiling point is more. Which is having more molecular weight? You tell me. Bismuth thine is having more molecular weight now, so it should have more boiling point. This is general weight. I'll explain one general concept also. I given what is boiling point and how boiling point depends on the molecular weight based on this relation. Now see, once look at this one general example we are discussing. In one beaker take water. Take water. In another beaker, this is water. In another beaker take petrol. This is petrol. Okay. First of all tell me boiling point and boiling point. Volatility means it is the ability to convert into vapor. Volatility property. Boiling point, here also volatility. See, water and petrol, petrol is highly volatile. If you take some petrol in your hand, it will evaporate easily. You no need to heat up. Automatically it will be evaporated. Highly volatile, more volatile. Volatility means ability to convert it into vapor. More volatile. Water is less volatile. If volatility is less, boiling point is more. General relation. If volatility is less, boiling point is more. Water is less volatile, having more boiling point, 100 degrees centigrade. In case of petrol, more volatile, less boiling point. Remember this relation. Okay, because on hydrates questions are coming like this: which of the following is more volatile, which of the following is less volatile? Okay, clear? If you know which is having more boiling point, you can predict. Yes or no? If you know boiling point relation, then you can guess which is more volatile, which is less volatile. Yes or no? Clear? What is the relation between volatility and boiling point? If boiling point is more, volatility is less. If boiling point is less, volatility is more. Now coming to hydrates boiling point. Boiling point is directly proportional to molecular weight, which is having more molecular weight, BiH3, because as we move down the group, weights increases, atomic weights increases now, so molecular weight also increases. So what is the expected boiling point order? Adiba, tell me expected boiling point order. What is expected boiling point order? Tell me fast, Adiba.
Increases from NH3 less than PH3 less than.
You Bhakti, NH3
less than PH3 less than PH3 less than
Hmm.
SpH3 less than BiH3.
Oh, very good. You have good memory, Adiba. First year, yes, she said good. In first year, we have one concept: consequences of hydrogen bonding. Because of hydrogen bonding, ammonia boiling point is more than that of pH3 and ASH3 except this is expected, but expected is wrong. We explained under consequences of hydrogen bonding in chemical bonding, right? Because of hydrogen bonding, see, because of hydrogen bonding, what happens? Here one ammonia, here one ammonia, here one ammonia molecules are there. All these come close together and get associated. And weight increases or not? All are adding now, so weight also increases. If weight increases, boiling point also increases. This is expected, but this is not correct. Due to hydrogen bonding, ammonia boiling point is more than that of pH3 and ASH3. Don't keep it first, okay? After ASH3, ammonia will come. This is expected, but what is the actual? And sorry. pH3, ASH3, ammonia. SpH3 and BiH3. This is correct. This is wrong. Now my question to you. Which is having more boiling point here, girls?
BiH3.
BiH3. Tell me, more boiling point. More boiling point means volatility is? Tell me, girls, more boiling point means where it is?
Yes.
More boiling point means less volatility. So, very, very important question. Which of the following is a less volatile hydride? BiH3 is a less volatile hydride. Less volatile hydride. pH3. Less boiling point, more volatile. I'll give you another terminology also, Adiba and Bhakti. Another terminology means enthalpy of vaporization. According to thermodynamics, enthalpy of vaporization, amount of heat required to convert into vapors, is called as enthalpy of vaporization. Which is having more enthalpy of vaporization? Which is having more boiling point? BiH3, more boiling point. So you have to give more heat to convert it into vapors. That is called enthalpy of vaporization. Okay, right below here only. More enthalpy of vaporization. More enthalpy of vaporization. More enthalpy of vaporization. Less enthalpy of vaporization. Less enthalpy of vaporization. So we completed stability, we completed reducing property, we completed Lewis basic character, we completed boiling points. Last topic, bond angle. Dipole moment is direct only, that is directly proportional to negativity, electronegativity. Next, bond angle. Let us close after bond angle concept. Small topic, bond angle. And please revise GOC, both of you. Okay, I sent videos, playlist also. I made playlist.
Sir, a GOC and hyperconjugation.
I'll make today. I'll prepare today. Okay. Adiba, are listening? Adiba. Second year organic will be very hectic. I am saying before only. If you're not thorough in the general organic.
I put status, sir. I put status.
Okay, no problem. Your wish. Your wish. No need to listen videos. If you have our notes, first year note, then that is enough. But revision is important. Okay. Last topic, bond angle. Small topic. In college. No. Other track is complex, I think. Once see, complex, inorganic only. That is also. That is inorganic only. Inorganic only, that is. Bond angle. Bond angle. Angle between two adjacent atoms. Angle between two adjacent atoms. For example, I'm taking AB2. Angle between these two is called as bond angle. Theta is the bond angle. In chemical bonding, we did already this topic, bond angle topic. Tell me, how bond angle depends on the electronegativity? Any idea? According to chemical bonding. In chemical bonding, under bond parameters, we did this. Any idea, Adiba? Any idea? Bond angle. Case 1 and case 2, we have two cases. According to chemical bonding, when central atom is different, and surrounding atoms are same, then bond angle is directly proportional to electronegativity of central atom. Bond angle is directly proportional to electronegativity of central atom. Once look at this. NH3, PH3, arsenic, and so on, antimony, bismuth. You tell me. Here central atom is nitrogen, central atom is phosphorus, central atom is arsenic, and so on, central atom is bismuth. When central atom is different or not? Different only. Surrounding atom. What is surrounding atom here? Hydrogen. What is surrounding atom here? Hydrogen. What is surrounding atom? Hydrogen. Surrounding atom is same. Then bond angle is directly proportional to electronegativity of central atom. Which is more electronegative here? Nitrogen or bismuth? Which is more electronegative? Nitrogen. Down the group electronegativity decreases or not? Nitrogen is more electronegative, so it is having more bond angle. So what is bond angle order? Bond angle order. NH3 is more than PH3, greater than dash dash dash. I am writing directly PiH3. NH3 is having more bond angle. More bond angle. In chemical bonding, we did this. Can you guess case 2?
Central atom is same and side atom is
When central atom is same, and surrounding atoms are different. Guess, Adiba? Then bond angle is directly proportional to size of surrounding atom. Look at this. NF3. Actually, this is not hydride, but I am giving and revising. Important for this chapter. In halides, we have this. I am giving here only. NF3, NCl3, NBr3, and Ni3. Whose surrounding atom size is more? Iodine or fluorine? Whose size is more? iodine size, down the group size increases. Iodine size is more. If size of the iodine is more, bond angle is more. So bond angle order, PA order. Ni3 greater than NBr3 greater than NCl3 greater than NF3.